The systems running a refinery, a power station, or a chemical plant are almost never PLCs. They're a DCS, a distributed control system. And if you have only ever worked with PLCs, a DCS can feel like a black box, a whole different world with its own vocabulary. It is not. The idea behind it is simple. In this video, I will explain what a DCS actually is in plain English. Then I will walk the architecture, field instruments to operator screen. And I will show you exactly how it differs from a PLC and from SCADA. Let us start with the word distributed. Quick note before we dig in. This is from PLC Simulator, where you can practice industrial control and supervisory screens free, right in your browser. No install, no license, no hardware. The link is in the description. Click the link in the description to try it free. Now, back to the DCS. So what is a DCS, really? A DCS is one integrated vendor-engineered system that controls a large, continuous process. The key word is distributed. In a small machine, you might have one controller doing everything. A DCS does the opposite. It spreads the control across many controllers placed out near the process they run. Each one handles a chunk of the plant, and every one of them is networked back to central operator and engineering stations. Why spread it out? 2 reasons. It keeps each control loop close to its field instruments, and it means no single failure can take the whole plant down. That is the heart of the idea, control that is distributed on purpose. Now picture the architecture from the bottom up. At the bottom is the field, transmitters, control valves, analyzers, all wired out on the plant. Those wire into the distributed controllers. The controllers are the workhorses. They run the actual control loops locally, right where the process is. Above them sits the control network. And this network is almost always redundant, 2 of everything. So a single cable or switch failing changes nothing. That network carries the data up to 2 places. First, the operator stations where the HMI lives and where the operators watch and run the plant. Second, the engineering station where the whole system is configured and the loops are built. Off to the side sits a historian, quietly logging every tag for trending and analysis. Here is the part that matters. All of that is one engineered system. From the field wiring to the screen, it was designed to work together. That leads to the hallmarks, the things that actually make a DCS a DCS. First, it is integrated. Control, the HMI, the alarms, and the historian all come from one vendor, sharing one database. Not 3 products bolted together. Second, redundancy is everywhere. Dual controllers, dual networks, dual power supplies. Reliability is the whole point. Third, it is engineered and supported by the vendor as a product rather than assembled by you from separate parts. And fourth, it is tuned for continuous, analog, loop-heavy process control, the kind of plant that runs for months without ever stopping. Those 4 traits, together, are the signature of a DCS. So how does it compare to the things you already know? A PLC is a fast, discrete, standalone controller. You program it, and you integrate it yourself. It is brilliant for machines and high-speed logic. I have a separate video on PLC versus DCS that digs into that split. It is linked below. SCADA is different again. SCADA is a supervisory layer that watches assets spread out across a wide area over slower links. And it is usually assembled rather than engineered as a single product. I cover that line in detail in the DCS versus SCADA video, also linked. A DCS sits right in the middle. Plant-wide, integrated, redundant, built for continuous control. That is the niche it owns. So here's what to walk away with. A DCS is one integrated, engineered system for a large continuous process. The control is distributed across many controllers, near the field, network to central operator and engineering stations. It is built around redundancy, and it is everywhere in oil and gas, power, chemicals, and water. Get that shape in your head, and the term stops being jargon. Now, go make it concrete. If you want to practice industrial control and supervisory screens hands-on, click the link in the description to start free at plcsimulationsoftware.com. No hardware, no install. Subscribe, New video every week. See you in the next one.